Hey guys, it's Mrs. Winger. You've made it to the second video on our exponent review, which is pretty much just all the remaining exponent rules. So as we go through these, a lot of them will start to click into place and hopefully re-jog your memory as to what we were doing and just put it all together. So again, just like last time, I would get out a blank piece of paper and a pencil so you can follow along. There's going to be moments in this video where I pause it again and have you guys try some on your own, which is really, really important to do. And then you can hit play and check your answer and compare it to mine just to make sure you're on the right track and you're getting the hang of it. So let's get started with the first of these review rules is being the product rule. And so let me just write this down, what I mean when I say product rule. Product rule is when you have something like this and they're being multiplied in the middle right here. They're being multiplied. Also, if it's something like this, where you see one in parentheses right next to each other, that is also, we know that there's technically a multiplication sign in between them and that they're being multiplied. So both of these things, this one and this one, both show us to use the product rule because there's a multiplication sign in between. The other important thing that you might remember me stressing in class a ton is this part right here. They have to have the same bases or this rule does not apply. So for instance, if I have something like this, y squared times x squared, this does not follow any exponent rule because these bases, the x and the y, are not the same. So we're not going to use any, there is no rule for that. So you might remember in class we talked about what this rule would be, and the answer is that you add the exponents. Okay, and so going back to the very first example that I wrote up, I'm going to erase some of this extra stuff, the x squared times x cubed. If our rule is to add the exponents, then I know this would be equal to x to the 5th power. So let's think about why this is true. Okay, well, let's just keep going with the same example. X squared, if I want to expand that out, that's just x times x. And x cubed, if I want to expand this one out, that's just x times x times x. Okay, and how many x's is that? 1, 2, 3, 4, 5. So that answers this question as to why that rule is true and why that works. So let's do some examples with them. First one up, I have 3 squared times 3 to the 6th. There's a multiplication sign in between, so I know I'm going to be using the product rule. They do have the same basis, so I know I just simply add the exponents. 6 plus 2 is 8. So my answer there is going to be 3 to the 8. That's going to give us a really big number if we calculate that on our calculator, something I would not expect you to know. I'm just going to box that one in and not type that on my calculator and figure out what that is. Okay? All right, I want you to take a second and pause the video and work on this second one right here. We will do this third one together, but I want you to pause the video right now and do the second one and check your answer after. Okay, so check your answer with mine. I got a final answer of y to the 11th power just by adding my exponents together. All right, let's look at the third one. I have 2 different letters involved in this problem, and let's think back to the rule which tells us you can add the exponents if the bases are the same. So the bases that have a base of c, I can add those together, and the bases that have a base of d, I can add these together. I'm not going to be doing any weird mixing or matching or anything like that. I'm adding together the ones with the same bases. So the c's, the one circled in blue, would give me c to the 7th power, and the one circled in red would give me d to the, now what power is this? Now I'm going to erase some of this just so we can go back and look at this. This one right here has an exponent of 1 on it, so don't forget that if there's not technically a little exponent, it is the number 1. It's not 0 because we learned last time anything to the 0 power is the number 1. Well, since this right here does not say 1, it says d, we know there's actually an exponent of 1 on it. So make sure you include that when you add together your exponents. So that's my final answer, c to the 7th times d to the 4th. All right. Awesome. So let's do some review of this exact same rule, the product rule, this time when we have coefficients. And coefficients are just these regular numbers right here out in front. And there's nothing fancy or weird. You're just going to multiply those together like normal. The reason I'm multiplying is just because of the sign right here. It's telling us to multiply. So let's do that. Let's multiply together the coefficients, so the 4 and the 3, gives us 12, and use the product rule to put together the x squared and the x to the 5th. Tells us to add the exponents, which would give me x to the 7th power as my final answer. Okay? At this time, go ahead and pause the video, and I want you guys to do this one right here on your own, and when you're ready, unpause it to check your answer. Okay, so check your answer with mine. I got negative 20 x to the 5th times y to the 4th. I could see this part messing people up because some people might have forgotten that on that term right there, that last y, there is technically an exponent of 1. So when you add that one together with the y to the cubed, that's what gives you y to the 4th. All right, so let's look at our second rule for today, which is the power rule. The power rule, just to remind you what that is something like this: x squared all to the 3rd power. Okay, and our rule with that is, what do we do with these exponents? It's you multiply them. So in this example that I wrote out for you, that answer would be x to the 6th power, because 2 times 3 is 6. All right, I want to answer this question over here. Why is that true? Why does that rule work? Well, let's expand it out just like we did with the last one. X squared cubed means we're taking x squared, and I want to multiply it by itself 3 times. That's what this means. Okay, now think about the rule that we just learned, where if we have the same bases, all 3 of those are the same because they all have an x, we add the exponents together. So let's add these together. 2 plus 2 plus 2 is 6. So this works because you're really just doing the product rule, the rule that we just previously learned, after you expand it out like this. All right, so let's do some examples. 4 to the 6th power cubed, what do I do with these exponents? I need to multiply them together. 6 times 3 is 18, so this gives me 4 to the 18th power. That is going to be a huge, huge, huge number, and I would not expect you to know that ever, and honestly wouldn't even expect you to type that on your calculator because it's going to be such a large number. Okay, let's look at this next one where there's more on the inside of the parentheses than just one thing. So what happens to the exponent? Does it go to both? Do you pick your favorite letter? Does it go to the one it's closest to? Where does it go? And the answer is that it goes to both. So I need to send this 4 to both of these exponents using multiplication just like the last one. So that gives me x to the 8th power and y to the 20th power, because that 4 is going to both. I'm going to have you do the third one on your own, and I'm just going to give you a quick hint. It is just like in the second one we did, where the exponent went to both. When you have a division one and an exponent on the outside, it's the exact same thing. It's still the power rule, and the exponent is still going to both. So go ahead and do that, and I want you to pause your video and hit play when you're ready to see the answer. Okay, so here's my answer, x to the 60th power over y to the 30th power. I got that from multiplying the exponent of 5, both to the exponent in the top, which was 12, and in the bottom, which was 6. Now, I see sometimes students look at this and think that that's a fraction like this, and they try and reduce it and say that that's 2. That is wrong, because this is not a fraction. Those are exponents, very, very different. So what this is saying, it's not the number 60, it's asking you to do x times x times x times x, dot, 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 60 times. So it's not the number 60, it's actually just the letter x written a bunch of times. So we can't just divide that, because the letter in the bottom is not x, it's y. So I can't divide things out because I do not have the same bases. This and this are different bases. All right, let's do some examples where we have coefficients now. Just like the last time, this is not going to complicate it or add any new rules. It's just that the exponent also needs to go to those numbers. So anytime you have an exponent on the outside, just make sure it's going to every single term on the inside. So what is this going to look like? It's going to be 2 to the 5th power. Now, how did I get that? How did I know it's 2 to the 5th? Remember, technically there's an exponent of a 1 right here, so when I multiply it together, 1 times 5 gives me 5. c cubed, or c to the third power. I'm going to multiply it together with the 5, and I'm going to get c to the 15th. And lastly, I'll get d to the 5th power, because technically it already had a 1, and I'm just multiplying it by the exponent of 5. And that's my final answer. Okay, I want you to do number 2 on your own. Pause your video right now and check your answer back with me when you're done. Okay, I want you to look at what I have boxed in green. This is the correct answer. I took my exponent of 3 and I multiplied it to the top exponent and to the bottom exponent. Sometimes we panic when we see negative numbers, and just ask yourself, is the negative included in the parentheses or not? The negative 10 is in a set of parentheses because the whole thing is in parentheses. So when I distributed that exponent of 3, both to the top and bottom exponent, I put this one in parentheses just to make sure that I didn't mess up anything with the negative. So then over here, what I wrote in black down here, I just wanted to check my work. If you ever feel a little bit iffy about your work, one of the things I kept saying in class was, when in doubt, expand it out. So that's what I did. I took this whole thing, which was a over negative 10 cubed, so I just wrote a negative 10 times itself 3 times, just to confirm that I was doing the right thing. So in the top, a times a gives me a cubed. And in the bottom, negative 10 times negative 10, that's positive 100, times it by another negative 10, and that's what gave me negative 1,000. So what I have in green, boxed in green, and what I have boxed in, I'll box this in red, are the exact same thing, just sort of 2 different ways you can think of getting there. One is just by expanding it out and confirming that all the rules work, and the other is just by using our rule and taking that exponent of 3 and sending it to both top and bottom. Okay, let's do the last one together. I'm going to pause my screen and erase it so I can start fresh. Okay. So I have an exponent on the outside. I'm going to do the same thing I've been doing and send that to every single term, all 3 of them, and see what I get left over. So that would be 3 to the 4th, m to the 20th, because I multiply exponents, and 2 to the 4th. All right, so let's try and simplify a little bit just what these are, since these are regular numbers. I'm going to start going this way just because I've run out of room on the right-hand side of my screen. So 3 to the 4th, if you don't have a calculator, here's how you can figure it out. I'm writing at the top of my screen here. 3 times 3 times 3 times 3. Just write it out 4 times and figure it out one piece at a time. 3 times 3, we know that that's 9. Times that by another 3, and you get 27. Times that by another 3, and you get, that's a little bit of a hard one, 27 times 3 gives you 81. So 3 to the 4th power is 81. And now let's figure out what is in the denominator. 2 to the 4th power. So what is that? Again, if you don't have a calculator, I'm going to write at the top of my screen again. I can just expand that out. 2 to the 4th power is the same thing as 2 times 2 times 2 times 2. And just figure it out one piece at a time. 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. Okay? That looks almost good to me. The only thing I would do next is just double check and see if you can reduce this fraction right here, 81 divided by 16. See if you can reduce it and get something more simplified. I'm going to pause and give you a second to figure that out and write it on your paper. Okay, and it turns out that already is in simplified form. I tried to think of some factors of both of these numbers. Factors of 16 would be like 4, 8, and 2, and factors of 81, well, it's not 4, it's not 8, and it's not 2. So therefore, this fraction cannot be reduced anymore. I don't even need to think through other factors of 81. If they're none of those, then it's not going to work. All right, awesome. So that's a review of the power rule. We have already learned that, but it's been a while, and sometimes those get tricky, so it was good practice. Let's move on now and talk about the quotient rule. Quotient, that's when you divide two things. So this rule is applicable for when you have something like this. x to the 5th divided by x squared. Again, the important thing here is this. They have to have the same base. If this was x to the 5th divided by y squared, there is no rule that you could use to help you simplify it. So it has to have the same base, like the one I wrote out. They both have x's, so we can use a rule on this. And the rule here is that you subtract the exponents. And I always subtract going from the top minus the bottom. So top minus bottom would be 5 minus 2, which gives me 3. Okay, and I'm going to talk about why this is true, but I want to show you what happened. What if this is flipped? If it was flipped the other way, what if instead of x to the 5th over y squared, or x squared, what if we had x squared over x to the 5th? Well, again, it's tempting to say, oh, well, 5 minus 2 is 3, so it must be x to the 3rd power. That is not true, though, because we are always going top minus bottom. So in this order, we're going to be doing 2 minus 5, which gives me a negative number of negative 3. And then from here, we know that we can make any negative exponent positive by flipping it to the bottom. Okay, so just be careful that you're always doing top minus bottom. Now, before we do some examples, and this is the last rule we're going to talk about today, I want to talk about why this is true just really briefly. Why does this work? Well, if we think of x to the 5th divided by x squared, let's expand it out. X to the 5th is just 5x's. X squared is just 2x's. And you'll notice that 2 of them cancel because you have them on top and bottom. And how many are left? 3. So that's why the answer ended up being y cubed. That was a terrible 3. Because 2 of them just divided out because you had that many on the bottom as well. All right, so let's do some examples of just some simple ones. So let's look at the first one. 4 to the 6th divided by 4 cubed. Notice they both have a base of 4, and so we can apply the quotient rule. Going in order from top minus bottom, I'm going to do 6 minus 3, which is 3. So this answer is going to give me 4 cubed. Now, I'm going to go ahead and figure out what this is. That's just 4 times 4 times 4. I know 4 times 4 is 16, and now I just need to times 16 times 4 and see what I get. And when you do that, this is something that would be okay to use your calculator on. You get 64, and that's going to be my final answer. Okay, I want you to pause your video and try the second one. Okay, so check your answer with mine. 4 minus 3 gives me 1, so my final answer is x to the 1st power. Or you could just write that as x. In fact, this is how we would prefer it. If you can write it more simple, you might as well do that. So instead of leaving it with an exponent of 1, just go ahead and write it as x. All right, let's do the last one together. I'm again just going to go in order of top minus bottom when it comes to exponents, and I'm just going to go through and do one at a time with whichever ones have the same bases. So let's start with the a's. A to the 7th divided by a squared, subtracting the exponents gives me a to the 5th in the numerator. Let's do the next one. B cubed minus b to the 1st power. Remember, there's an invisible 1 there. 3 minus 1 is 2, so that's going to give me b squared. And the last one, I have c to the 5th divided by c to the, again, remember there's an invisible 1 there. 5 minus 1 gives me 4, so that's going to be c to the 4th. There's nothing in the denominator. I could write a 1, or I could just box this part in as my final answer, and that's what I would suggest doing. All right, so let's do some practice when you have coefficients. Remember, coefficients are just these regular numbers out in front. Nothing weird happens at all. We're just going to divide them because all these questions tell us to divide, so we're just going to divide the numbers. Okay, so let's do the coefficients first. 6 divided by 2 gives me 3, and with the variables, x to the 4th divided by x cubed, I'm going to subtract them going top minus bottom, which would be 4 minus 3, which gives me 1. And I'm just going to write that as x. So my final answer is 3x. Okay? All right, I'm going to do the second one for you, and then I'll have you guys try and do the third one on your own. So first thing I'm going to do is look at the regular numbers, these coefficients here. Negative 15 divided by negative 3 is a positive 5. I can write 5 over 1 if you want, but there's really no point in doing that. Next part, the x's. I have x to the 6th divided by x to the 5th. 6 minus 5 is 1. So I'm just going to write an x in the numerator. Going to erase it so I can see a little more clearly for my next one. Y's have the same basis, so I can do the same thing. Subtract the exponents. 5 minus 3 gives me 2. The last one might seem a little weird because there's no other z. We just have this one right here. And so you might think, what do I do with that one? Because there's nothing to pair it up with. And the answer is if there's nothing to pair it up with, then you just leave it there. There's no rule to apply because there's no other z involved in this problem. So you still need to have it in there, but there's no exponent rule that we need to do on it. Okay? All right, at this time I want you to do the third one on your own, and when you can reduce fractions, I want you to. So pause the video and check in a second. Okay, so check your answer with mine. 36 divided by 54 can be reduced to 2/3, and I would like you to do that whenever you can. And just using my exponent rules for the m's, 9 minus 3 gave me 6, and 5 minus 2 gave me n to the third power, that last one right there. So that's my final answer. Probably just a formatting thing is I wouldn't leave the 3 there. I'd probably just center it maybe over here to make it look nicer. Make sure my division sign goes all the way across. But that's the correct answer. All right, my last, I actually have 2 more pages for you guys just to practice some of these rules mixed together. So at this point, I want you to pause the video and do all 4 of these on your own. They're a little bit more simple, and then I will do some on the last slide where they're a little bit more complicated. So pause the video and try doing all 4 of these on your own, applying all the rules put together. Okay, so here are my answers to these 4. At this point, I would pause it again just to give you time to check it. I want to talk about one thing, so before you start checking, I want you to hone in on this one right here, the third one. Notice when I subtracted my exponents, starting with the c's, I went top minus bottom. This time that would be 5 minus 7, which is how I got the negative exponent. And again, from the video the other day, negative exponents become positive by flipping them to the other side of the fraction. It also put together the rule of anything to the 0 power is just 1. Alright, so I'm going to give you a second to pause the video before we move on to ones that are a little bit more involved. Alright, so let's look at this first one. The first thing I notice is that there's a 2 on the outside as an exponent, and I know that's going to go to both the negative x and the y. Okay, so let's think about what that is. That would be negative x times negative x when I'm looking at this very first term. Let me write that out a little bit better. Okay, I just paused and wrote above in blue right here. What it might help you to think about in your head when you see that square on the outside, it's going to both the negative x and the y, but both of them are still in parentheses because the original problem did have parentheses. Why that's helpful is now I know that my answer is going to actually be positive x squared because I have a negative times a negative in this first piece right here. It's going to give me positive x squared. Y squared, the second term right here, nothing crazy with that. That'll just write it as y squared. All right, let's continue out this problem. I have times 8, x to the negative 7, and y to the negative 2. Well, I have a bunch of things being multiplied. If I want, I can come in here and put multiplication signs in between all of it if that helps me see it better. So what can I do? I can take things that have the same bases, so both of these have a base of x, and I can add the exponents together. And so what is that? 7 plus, or negative 7 plus 2 gives me negative 5. Okay? And I will, of course, make that exponent positive in a second, but for right now I'm going to leave it like that. Let's do the y's. When I add these together, 2 plus negative 2, I get 0. And we all know what that is, but I'm going to leave it there for a second. And this times 8 just needs to stay there because there's nothing to multiply it with, no other regular numbers, so it's no problem. I'm just going to keep it there. Okay, we know that this right here is really just the number 1. So I'm going to erase that actually and just write 1 just to help me save some space. So right now I have the problem as, I'm going to do an arrow and bring it up here and erase the screen in a second. X to the negative 5th times 8. How can I make the negative exponent a positive? By moving it down to the denominator. And so my final answer will be 8 over x to the 5th power. The 8 will stay because there's no negative exponent attached. Okay, I know that one got messy, so I'm going to erase my whole screen right now, and I'm going to have you guys pause it and do the second one on your own. Okay, my screen is erased, and now would be a really good time to pause the video and work out the second one. Alright, I wrote out the first step for you guys, and I wanted to write out the couple steps after that together. Notice all I did in that first step is take the exponent of 3 and send it to both of these, and I did leave the negative 6 in parentheses because it was already in the parentheses at the beginning of this problem. Same thing for the bottom. I took the 2, the exponent of 2, and sent it to both and using multiplication. So let's figure out what these are. Negative 6 to the 3rd power, that would be negative 6 times negative 6 times negative 6. Well, we can probably figure out the first part. Negative 6 times negative 6 is positive 36. And if we multiply that by another negative 6, we'll get negative 216. Not something I would expect you to know without a calculator. And for the denominator, 3 squared, that is something I would expect you to know. That's 9. X to the negative 8, I'm just going to leave that as is for the time being. Last thing I can do is I am going to take this, which has a negative exponent, and bring it up to the top. So let me make some room for that. Take the x to the negative 8, bring it up to the top as x to the positive 8, and now it's no longer down here. All right. And finally, I can write this with using my product rule. I have the same basis, so I can add the exponents. 6 plus 8 gives me 14, so that's going to be x to the 14th power, and my denominator is still 9. Okay? I could maybe reduce this fraction, negative 216 divided by 9. I'm just going to leave that as is for right now for time's sake. If you have a calculator, that would not be a difficult problem to do. I'm going to erase my screen and get you guys started with the next problem. So a good first step here is to distribute the exponents to everything and just rewrite what you have. So that gives me 3 to the 4th, x to the, remember we multiply our exponents here, so x to the 20th, y to the 12th, over x to the 12th, y to the 24th. After I multiply all those numbers together, that's what I get. Alright, now let's see what else we can do to clean this up a little bit. I'm noticing I have the same bases here, and they're being divided. What was my rule? Is that I subtract those exponents. So I'm just rewriting that 3 to the 4th for right now, and let's work on what this right here would be, those x's. So 20 minus 12 is 8, so that's going to give me x to the 8th power. Okay, and let's look at the y's. Same exact thing here. 12 minus 24 is going to give me a negative number. That's going to give me y to the negative 12th power. I'm running out of room here, so I'm going to take this whole thing I have and write it over here. So 3 to the 4th times x to the 8th times y to the negative 12 is what we had. Okay, so now I can take my negative exponent and move it to the denominator and make it positive. Okay, so I took it and moved it to the denominator and made it positive, which gave me this term right here. And just to further simplify things, I did write 3 to the 4th power as 81, just to give me a nice, clean final answer. Alright, that's it for today, you guys. Good job listening along. This video was a bit longer than normal because we had a lot of exponent rules to review, but there's no other work for today other than to thoroughly listen to this video and give you your efforts. So, again, come to office hours if you guys need help, and I'll be happy to help you out. Hope you guys have a great rest of your week.